Welcome back to the Essentials of Science. Today we're learning about volume. If you measure how long something is, that's a one-dimensional measurement. If you measure the area, like what we did in the previous video, that's a two-dimensional measurement. Whatever unit you are measuring in becomes units squared. This means that area increases faster than you might think. We discussed this a bit with how to buy pizza in the last video. Suppose we have a circle with a radius of 5 centimeters. How big is a circle that is twice as large? And by twice as large, I mean twice the area. It would only need to be an additional 2.07 centimeters bigger in radius, or 4.14 centimeters across. This is because of exponential growth. You are squaring your units. Similarly, you may have wondered why slightly larger TVs cost so much more. I'm about to use imperial units, I know, forgive me, but that's how TVs are measured in America. I'm working on changing that. So take a 45-inch and a 55-inch TV. How much bigger is the 55-inch? Not 10 inches, because you're viewing a two-dimensional flat surface. In terms of how much more screen does it have, the 55-inch is actually 50% larger than the 45-inch. A 64-inch TV is essentially twice the size, as in twice the viewing area, of a 45-inch TV. But this video isn't about surface area, it's about volume, which is a three-dimensional measurement. Let's go back to our circles. The circle on the right is twice as big as the circle on the left. Let's take a sphere with the same radius as the smaller circle. When we say, how big would a sphere twice the size be, we mean how big would a sphere with twice the volume of the original one be. And the radius of that sphere is even smaller, only 1.3 centimeters bigger, or 2.6 centimeters in diameter larger. This is because we are dealing with units cubed. The exponential growth rate is larger, so volume grows much more quickly than surface area does. Volumes and shapes are also tricky. Imagine we have a cone and a cylinder, both with the same radius and height. How much less space does the cone take up? It actually only has 1/3 the volume of the cylinder. It's hard to judge if a broad flat shape or a tall narrow shape has the most volume just by looking at them. The largest building in the world, the Boeing Everett factory in Washington, has a volume of over 13 million cubic meters. That's over 6 times the volume of the tallest World Trade Center building, which I only picked because they were perfectly square so I could calculate their volume easily. Children really don't understand volume. You show a kid 2 identical glasses with identical amounts of liquid in them, and they understand that they're both equal. But if you pour one of the contents into a tall skinny glass right in front of their eyes, they will say the tall skinny glass has more water in it. Come on, Timmy, get it together. What you should understand about the volume of an object is that it's the quantity of space enclosed within a surface area. It's not the amount of space that the object itself takes up. What do I mean by that? Well, have you ever tried to put something in a box or the trunk of your car and it just doesn't fit? Maybe it's just too wide, too long, or because it's weirdly shaped, it just doesn't fit. Some objects take up more space in their environment than the shape itself takes up, while others don't. If an object has no concave surfaces, then the volume of space it occupies in the environment perfectly matches its internal volume. Cubes, cuboids, prisms, pyramids, tetrahedrons, spheres, cylinders, cones, and more are essentially like this. Although when you try to put objects, such as these, into boxes of a different shape, you find there is a lot of unused space. If you've ever had to move, then you know all about the struggle of fitting the most possible objects into the smallest possible space. For example, if you have a box and a perfect sphere that is the exact same diameter or width of that box inside of it, how much of the box are you using? Surprisingly, you are only using a little more than 52% of the box. Almost half of the box is wasted space. Let's pause here to emphasize the difference again between surface area and volume. A circle inside of a square of the same diameter takes up over 78% of the surface area. This is much more space than the sphere inside of the box, because again, volume grows by units cubed. The rate of growth is greater. Most objects in the universe are not regular shapes like cubes or spheres. These objects have irregular sides, including concave faces that angle inward, and so the volume of space they occupy in the environment, in a sense, is greater than their practical volume. If we could make all objects liquid to transport them, then you could fit a couch into the trunk of a car, but that's not the world we live in. Going back to regular shapes, they all have a formula for their volume. Some of them are complicated, most are simple. But how do you find the volume of a horse? You may be surprised to know that there is no formula for the volume of a horse, but it has a volume, so what do? To calculate the volume of an irregular object, use water. If you can find a way to measure the displacement of water or any liquid that an irregular object causes by being submerged, then that tells you the volume of that object. This is the source of the legend of Archimedes and the word Eureka. Hero of Syracuse needed a way to find out if his golden crown was pure gold. A mixture of impure metals plus gold could still look just like pure gold, but would be worth much less. Gold is a pure element, which means it has a definite density. Density is the topic of the next video, but in order to solve this problem, they needed to know the volume of the crown. Density is mass divided by volume, and the mass of the crown was easy to find. Archimedes sat in his bathtub, and when he noticed the water level rise as he sank in, he shouted Eureka, which means I have found it, as in he found the solution to the problem. Supposedly, Archimedes ran out of the bathtub naked through the streets of Syracuse, shouting Eureka. As fun as that is to think about, it's almost certainly apocryphal, meaning it's a popular story, but there's no proof it ever happened. A bit like George Washington and the cherry tree. Volume can be measured in units like centimeters cubed, but a cubic centimeter is a perfect shape, a cube. And so I generally think of volume as a measure of how much liquid would fit into a container shaped exactly like the object. So I usually think of volume as being measured in milliliters or liters, because a liquid fits any shaped container. But again, a milliliter and a cubic centimeter are the same volume. Earlier I showed you that a sphere inside of a box of the same width only takes up about 52% of the volume of that box. Here we see a sphere and a cube of the same volume. The sphere needs to have a diameter that is 24% wider to match the volume of the cube. In the next video, we will be discussing density, which is a property of matter. Thanks for watching.